Math 1332, Chapter 2, Set Theory, Section 2.2, Subsets and Set Operations, Video 3, Complement of a Set. In this chapter, in this section, we're going to discuss set operations. You already know what operations are mathematically speaking because you've done them since you've learned that 1 plus 1 is 2. An operation is basically an action that takes one or more objects and turns them into a new object. For example, addition is an operation that turns 1 and 1 into 2. Subtraction, multiplication, and division are also operations. There are some operations that only require one number, such as taking the square root. For example, square root will take the number 9 and turn it into 3. That's an operation. A set operation is an action that will take one or more sets to produce a new set. In this video, we're going to talk about an operation called the complement of a set. The complement of set A, written symbolically, this wasn't supposed to be here, so that I could write it now. The way you write the complement of a set, and by the way, complement in this context is spelled with 2 E's. There's no I in it. The complement of a set A, written symbolically as A with an apostrophe, and you would just read that, A complement. Let me check something real quick. Yes. I was checking with the textbook that I'm using for the class I'm currently teaching. This is the notation they use for complement. I've seen no fewer than 5 ways to represent the complement of a set, so I wanted to make sure I was using the one that my class is going to use. Written symbolically as A with an apostrophe and read A complement, or complement of A, is the set of all elements in the universe, so we have to have a universal set defined, that are not elements of A. So essentially, it's the set of all elements outside of a given set, but still within the universe. In set builder notation, you could say that A complement is the set of all x's such that x is an element of the universe and x is not an element of A. So you must be in the universe, but you cannot be in the original set. Just think of it as the opposite of, or what's excluded from a set. Let's take a look at 3 examples and then make a couple of observations. Example number 1. For our universal set, let's pretend it's the numbers you could roll on a single die, standard die. 1, 2, 3, 4, 5, 6. And let's say within that universe we have set A, which contains the numbers 1, 2, or 4. What is the complement of A? To put it simply, all the numbers in the universe that are not represented in A. A contains 1, 2, and 4, but there are 3 numbers in the universe that are missing. The numbers that are missing from set A are 3, 5, and 6. And hence, A complement contains 3, 5, and 6. It's really quite a straightforward concept. Let's take a look at the next example, which has sets that are described and not listed in roster form. U is the set of all mammals. Okay, all mammals in the world. Humans, dogs, cats, elephants, porpoises, whales. Yes, they're both mammals. And any other critter classified as a mammal. Let's let D be a set inside that universe, the set of all dogs. How can we describe D complement? Well, remember, to be in the complement, you must be in the universe, but not in the given set. So if we're in the universe, that means in this context, we're a mammal. So we need to start by saying the set of all mammals. But not the ones in the set D. The elements of set D are all dogs, so the things outside of set D are not dogs. The set of all mammals that are not dogs. And it's important that we say the set of all mammals, because if we just say the set of animals that aren't dogs, that might include birds, lizards, and turtles, which were not included in this universe. The generic way to describe a complement is to say everything that belongs to the universe that isn't something in this set. Everything that's a mammal that isn't a dog. For the last example, we're going to let our universal set be Z. Now remember, Z is the symbol for the integers. So if it helps, you could write them out in roster form. Remember, the integers are positive and negative whole numbers. So we have to start with ellipses. -3, -2, -1, 0, 1, 2, 3, ... all the positive and negative whole numbers. Now, what set are we going to take the complement of? Well, we're going to take the complement of the natural numbers. Natural numbers complement. So think about what this is asking. This is asking which numbers in this universe are not natural numbers. If you've forgotten, the natural numbers are also called the counting numbers because it's the numbers you count with. So without the apostrophe, the natural numbers would be 1, 2, 3, 4, 5, 6 forever. The complement of the natural numbers in the universe of integers is everything else. Think of it as going to the universe and erasing the natural numbers. What's left? All the negatives and 0. -3, -2, -1, 0. In fact, if you're having trouble visualizing complements, when sets are written in roster form, you can literally do what I just said to think about. You can literally say, let me take the universe, cross out everything in the set whose complement I'm taking, in this case, cross out all the natural numbers, and then whatever's left is your complement. I could have done that up here as well. I could have taken the universe, stricken out 1, 2, and 4 because they belong to set A, and then whatever was left over was my complement. A little trickier to do in descriptive because you don't have elements to cross out. There's 2 observations I'd like to make about complements before we wrap up this particular video. For any universe U, there are 2 statements we can always say are true. The first statement is, what do you get if you take the complement of the universe? Think about it. Think about it in roster form. If we listed the whole universe, we would find the complement of the universe by going to the universe and crossing out everything in the universe. Well, in a given situation, what exists outside the universal set? Think about the Venn diagrams. What do we write outside the boxes? Nothing. The set of elements outside of a universe is empty, which means for any universe, the complement of the universe is the empty set. Think of it as saying the opposite of everything is nothing. That's observation number 1. And I bet you can figure out what observation number 2 is. It's kind of like this in reverse. Actually, there's 3 observations we're going to make. For any universal set, what do you think the complement of the empty set is? All right, we got a box of numbers, and inside of it, we have a circle that's empty. There's nothing inside of it. And we're being asked what's outside of it. Well, if there's nothing in the circle, then that means everything is outside the circle. The complement of the empty set is the universe. For the last observation, let's say we take any set, not necessarily the universe, but some set inside of the universe, take its complement, but then take the complement of the complement. Now, this might take a little bit of thinking, or it may not. What do I mean by the complement of the complement? Well, with one complement, I'm saying what is outside of A, but still inside of the universe. So visually speaking, if we were to draw a Venn diagram, there's a universe, there's A. Where in this Venn diagram would be the elements of the complement of A? In other words, where in the Venn diagram are the parts that live outside the circle? Well, the answer is over here. If we had to label these regions, there's only 2 of them. We'll say region 1 is the circle and region 2 is outside. If I were to ask you which of those two regions represents the complement of A, you would say region 2. It represents outside of A. But now if I put another complement on it, I'm asking what is outside of the outside of A. In other words, I am asking you what in the universe does not belong to region 2. Remember, region 2 was the visual representation of the complement of a set being the outside of a circle. Well, if I were to shade in everything out here, then the complement is asking you, the complement of the complement is asking you what's not shaded. And the answer is the inside of the circle. What is outside of the circle? The inside. Does that mess with your head? It might. It might be easier if we had a numerical example. Let's go back to the first universe we had, which contained 1, 2, 3, 4, 5, and 6, and set A, which contained 1, 2, and 4. And I asked you what was its complement, and the answer was everything else, which was 3, 5, and 6. But if I ask you for the complement of the complement, I'm asking you for the complement of this set. Which numbers in the universe are not in here? 1, 2, and 4. Which, if you'll notice, was the original set. And in general, the complement of a complement is the original set. You can see that up here. If we took the complement of the universe, we would be taking the complement of the empty set, which is the universe. We're back where we started. And vice versa, if we took the complement of the empty set. The concept of complement is pretty straightforward. Which numbers in the universe are not in this set? Visually, complement means on the outside of. And for any universe, we can say these three statements. The complement of the universe is the empty set. Complement of the empty set is the universe. And for any set, if we take the complement of its complement, we get back the original set that we started with, like in this example.